Hello, in this video we are going to be looking at extraction of iron from its ore, hematite. Now iron is quite an important metal that is used in many areas, okay, making it's applied in industrial uses, making of different types of tools, and also we have appliances in the homes that are made of iron. Now this iron is mined, okay, from the ground, okay, from the earth's crust, and after the mining we obtain what we call the iron ore. And the iron ore, what we call the iron ore, is what we mine from underground. The most common one is hematite, okay, you can spell it like this or like that, okay. So hematite is the iron ore from which iron has to be extracted from. Remember, these are more or less like rocks, okay, they're just rocks that are mined from underground. They are just rocks that are mined from underground, and they are mixed with different things, okay, with sand, okay. So now how do we get the iron from this rock, okay, from this rock called hematite? Now there are other type of ores where iron comes from. For example, you have magnetite and siderite. All those are also common types of iron ores, okay. But the most common one that we'll discuss here under O level is hematite. Now hematite, it has the formula, okay, iron, okay, it's iron 3 oxide, okay, iron 3 oxide. So this is the formula for hematite, iron 3 oxide. Okay, so all this extraction happens in what we call a blast furnace, a blast furnace. Now a blast furnace is just a long tower, okay, about 30 to 40 meters high. And these blast furnaces, they are made of, if you look at the diagram here, they are made of bricks, okay, mostly they are made of bricks. And why do they use brick? Because brick can withstand a very high temperature, okay, it can withstand a very high temperature. So in our previous video we said there are three methods of extraction of these metals, okay. There's electrolysis, there's reduction, and there's also thermal decomposition. So here what we're talking about is the reduction method, okay, is the reduction method. And if you haven't watched the previous video under metals, please watch the previous videos under metals. And also you can also look at the extraction of aluminium, okay, there are many things I explained there. So the method being used here is called the reduction method, and we'll get to that why we're calling it reduction method. So this is the iron ore, okay, this is hematite, and we want to simply extract our iron from this, okay. Now in order for us to extract this iron properly, okay, we have to put it in the blast furnace, okay. Everything will be done inside the blast furnace here, the process called reduction. Now there are several things that are added in the blast furnace that we call the charge, okay. So everything that we are adding in this blast furnace, we call this the charge, okay, we call this the charge. So these raw materials are called the charge, and among these the hematite itself is one of them. We also add what we call coke, okay. Now coke is simply carbon, okay, is simply carbon, okay. We have coke or carbon. And then we also have limestone, okay, we also have limestone, okay. All these are raw materials that are fed into the blast furnace, okay. So the raw materials fed in the blast furnace is 1 hematite, 2 coke, and the third one is limestone. And the chemical name for limestone, the chemical formula is calcium carbonate. So these are what we call the charge, and they are fed right here in the blast furnace. You have things that collect them. They are called hoppers. So I'm going to be mentioning a lot of things as we go on. They are called hoppers. So this is a hopper. So they are called hoppers, and they could be more than one. This is what will receive the charge. That's what will receive the charge. So now, once these are fed in the blast furnace, they have reasons, and we'll talk about those reasons. So within the blast furnace here, I said it's made up of brick inside, and outside it's made up of steel. And you have all these things fed here. Now, the other thing that is fed into the blast furnace, as you can see, apart from the charge, is air. Now this is just not ordinary air. This is very hot air. Very hot air. So you have hot air being fed into the blast furnace as well. Very, very hot air. And one of the things that we find in air is oxygen. Oxygen. So I'm building up from there. So oxygen goes inside, and you have to understand that because there's oxygen here and there's carbon, these two would definitely cause a reaction. So there's hot air inside this blast furnace, and then also you have the charge coming in. So you have two things that are fed: one, hot air, and the charge. Hot air as well as the charge. So this blast furnace is divided into 3 zones. You have zone 1, you have zone 2, and you have zone 3. And these zones have got different types of temperatures. For example, the temperature here at zone 1 is about 200. I don't know what color I should use. It's about maybe use this one. It's about 200. Don't know, that's not visible. It's about, let me use black. Yeah, so it's 200 degrees Celsius. Then here zone 2 here, it's about 700 to 800. You also need to know these you need to know these temperatures. And here it goes to about 1200 degrees Celsius. And if you have another one just below here, it could go up to 2000 degrees Celsius. 2000 degrees Celsius. So it's important for us to know these temperatures. So very important. So let me erase some of the things that we don't make a mess. So we're saying the whole process is the whole method here. The whole method we're using here is the reduction method. So on the charge here, we have 3 things. And the first reaction that is going to take place, oxygen here will react with the coke. So reaction number 1 to take place, the oxygen will react with coke. Remember we said coke is simply carbon. And these two gives us carbon dioxide. These are gases. This is in solid state. This is a gas as well. Okay, so it's the first reaction that happens, and this is a reduction type of reaction. Okay, not really reduction, it's oxidation. Okay, this is oxidation. Oxygen oxidizes carbon to this. Okay, and then the second reaction that will take place is this carbon. It's still plenty inside. It's going to now react with the product, which is carbon, that is carbon dioxide. This now gives us carbon monoxide. This is also a gas. So now what's happening here? If we try to balance the equation, how about I put a 2 here? I think this balances the equation. So this is the second reaction that is taking place. Okay, so the first reaction, carbon reacts with oxygen to give this, and then the third reaction now, so the third reaction is where hematite now is reduced, because we have the reducing agent now. So I said hematite is Fe, like this. Okay, is now being reduced by carbon monoxide. This will give us iron now. We leave space for balancing the equation to give us iron plus carbon dioxide. So balancing the equation, we have 2 atoms of iron here, then carbon we've got 1, 2, then oxygen, that is 2 here. Oxygen we have about 5. Okay, so to try putting a 2 here. Okay, a 2 there. This makes carbon 2 plus 3, I mean plus 1, that makes it okay, let's do this. Carbon 1, 2, oxygen, that is then 4. Okay, so we try to put a 2 here. Okay, and a 2 here. Okay, so we have 4 atoms of oxygen, 4 atoms of oxygen, 2 atoms of carbon, 2 atoms of carbon. Okay, I think like this it is balanced. So this is gas. The iron, we always get it in molten state. This is gas as well. This was solid. Okay, so we have carbon and carbon being produced, and these leave here as waste gases. Okay, they escape as waste gases. And the other thing that's going to happen now, this limestone now, because of the heat inside here, there is what we call thermal decomposition. Okay, so thermal decomposition is where the calcium carbonate will simply decompose, okay, because of heat, to calcium oxide plus carbon dioxide. So you notice carbon dioxide being produced in many reactions here. So this is done because of what? Heat. Okay, now remember I said these things they have sand. Okay, so the last reaction that will take place now is the reaction where calcium oxide reacts with the sand. So calcium oxide plus, okay, the chemical name for sand is silicon dioxide, and this will give to us calcium silicate. Okay, right, so we have 1 2 3 4 5 reactions that are taking place here. Okay, so I said the ores of iron. You have hematite. Okay, we have hematite. So this is hematite, that's the formula. And then we have magnetite. The formula is there. Okay, iron 3 oxide, iron tetraoxide, and then you have siderite. Okay, iron 2 carbonate. Okay, so we are demonstrating the extraction of iron using hematite. Then extraction, we said it occurs in the blast furnace. Okay, so the charge, so to extract iron, 3 substances called charge or raw materials are mixed together: the iron ore, which is hematite; limestone, which is calcium carbonate; coke, which is pure carbon. So this charge is crushed and placed into the top of the blast furnace. It is then roasted in air. So roasting in air means it is burned in air, and in air we have oxygen. That's why coke reacts with the oxygen in hot air to form carbon dioxide. The reaction is called oxidation. So I've already demonstrated this. So hot air and oxygen is forced into the bottom of the blast furnace. Okay, and this is the first reaction taking place. Then carbon dioxide rising up reacts with more coke. Okay, so the carbon reacts with more coke to give to us carbon monoxide. This carbon monoxide now is our reducing agent, which should reduce iron 3 oxide to this. Okay, so I don't know how I balance the equation there, but this is a properly balanced equation. Okay, so iron 2 oxide is reduced in this equation. You have your iron here. So iron goes to the bottom of the furnace where it is tapped off. So then calcium decomposes. Okay, I've already explained this. Okay, and then it reacts with silicon to give us calcium silicate. Okay, so now what is happening here, we can go back to this diagram. So we've seen how these reactions are taking place. So the iron settles at the bottom here, and then the calcium silicate is on top of this. Okay, this is the blast furnace here. So you find that the calcium silicate will settle right here. Okay, the calcium silicate will be here. Okay, and then here is where you get your molten iron. Okay, molten iron. So the molten iron comes out like this. Okay, it's not yet pure, it has some impurities. Okay, and then okay, so uses of the slag. The slag is the calcium silicate. It is used in the manufacture of cement, and also it is used for making rods. Okay, so the iron that we have obtained is called cast iron or pig iron. So this iron here that we get is called pig iron or cast iron, but then it has to be burnt in oxygen once more to remove all the impurities, and that's when you get the purest form of iron that we call wrought iron. Okay, so here's just something for us to appreciate. Okay, this is what a blast furnace looks like in real life. Okay, so just a diagram here. So like I said, this is where you can see they are feeding in the charge on the hoppers. Okay, and you can see the temperatures here. Okay, you can see different zones. Okay, so what you are seeing here, I've already explained. This is where waste gases, carbon dioxide are coming out. This is where they feed in hot air. Okay, and these reactions will take place. and the molten iron is collected like that, and the slag is on top, it's collected on its own. So that's how this is the world's largest blast furnace. It was captured in 1931. Okay, so just for us to appreciate how these things are happening. Okay, so iron has got a lot of properties, okay, that are used. Okay, we're going to look at those. Okay, so here you can see how molten iron looks like. Okay, it's purely in its liquid form as it's being collected uh, from the blast furnace. Okay, now we have so much of the iron that is produced is refined and converted to steel. Okay, so we will look at steel. Okay, but what I want us to look at is talk about this first. Okay, so the iron that we get from the blast furnace is called cast iron. Okay, now this cast iron, it has a percentage of carbon dioxide. Okay, so once they burn it, okay, we said once it is burnt in oxygen, it is transformed into what we call wrought iron. Now wrought iron is actually what can I say, the purest form of iron, okay, with 0% of carbon, and it's quite soft, okay, because it has 0% of carbon. It's quite soft. But then we have what we call mild steel. Mild steel has got at least a percentage of carbon, and because of this you'll find that mild steel is a bit hard compared to wrought iron. Okay, it is hard and strong, and because of this it's used in making car bodies, okay, the shipping, building, okay, girders and bridges, and also nails and wires. Okay, now we have another type of steel now which has a very high percentage of carbon, about 1.5%. This makes it to be used in it's quite brittle. Okay, it's quite brittle because of its high carbon content. Okay, it's used in making of cutting tools. And then now there are special type of steels. Okay, special type of steel, and these special type of steel, when iron is mixed, you get an alloy called steel. So we have stainless steel, which is just a combination of iron mixed with chromium and nickel. It has a special property in that it will resist corrosion, and because of this it is used in making kitchen utensils, okay, cutlery, cooking utensils, kitchen sinks, industrial equipment, food and drink processing, because it resists corrosion. Then we have titanium steel, iron mixed with titanium. This one is able to withstand high temperatures. Because of this, it is used in making gas turbines and spacecraft. Then we have manganese steel, iron simply mixed with manganese. This one is very hard, and it is used in rock breaking machinery, some railway track, and also military helmets. So we can appreciate the uses of iron. Okay, as we've seen how it is extracted in the blast furnace, how they purify it, okay, and then how they are able to mix it with certain metals to give us all types of steels. Okay, so that is what we're going to cover in this video. I hope to see you in our next lesson. Please hit the subscribe button if you're not subscribed, and like and share the video as much as possible. We will appreciate that support.